Okay, I'm going to go over the 6.2 quick check. So first, if we're talking about some solid calcium chloride that dissolves in water, now we've done that in a baggie, and we know that it really does dissolve, and we should remember that it got hot. So the fact that it got hot, the surroundings are getting hot, then we know that the delta G must be negative. The reaction is giving off heat, and that's causing the surroundings to get hot. We can also think, okay, if we have a solid and it's turning into aqueous, then the delta S must be positive because it's getting much more random. And finally, because this actually does happen, then we know that delta G is a negative value. Okay, the other thing we could say is, well, if delta H is negative and if delta S is positive, that definitely is going to be a spontaneous reaction, so therefore delta G is negative. So that's how we can determine those three different signs. Okay, the next one is talking about the situations you might have. What would make a spontaneous reaction? Well, we'd say, well, plus and plus, that would happen at high temperatures, so not low temperatures. So that first one is not a good sample. If the delta S is positive, that's good, getting more random. And the delta H is negative, that's good, giving off energy. So this reaction, this situation is going to be spontaneous, and it doesn't have to be at high temperatures, it'll be high or low. So that one's going to be spontaneous at any temperature. Now just the opposite, negative and positive, okay, negative delta S, getting less random, absorbing energy, this one is not going to be spontaneous at any temperature. And finally, if it's negative and negative, okay, that is spontaneous at low temperatures. So the second and the fourth situations. Now the next one here, talking about entropy changes. So for entropy changes, again, we just do, products minus reactants. And this would be the entropy of the products, minus the entropy of the reactants. So what are we talking for this reaction? We need the entropy of CuO, okay, minus the entropy of copper, and minus 1/2 the entropy of O2. Now, unlike delta H formations, there are values for elements for entropies, and that's because there is a real value for zero, entropy. Anyway, so we're going to put numbers in all three of these. So it's CuO, which is 42.63 kilojoules per mole, okay, minus the value for Cu, which is 33.15, and minus 1/2 of the value for O2, which is 205.14. Okay, and these are all going to be kilojoules. Joules per Kelvin. And the answer comes out to be negative 93.09. And that's going to be joules per Kelvin. Now these values were joules per Kelvin moles, and we were multiplying by 1/2 mole or multiplying by 1 mole and 1 mole, so that's where those moles went away. Okay, so negative 93.09 joules per Kelvin. Okay, the other one here is talking about, if we have a change over temperature. What we have is we have a situation where there's a positive delta H and a positive delta S, and what we learned, like way back up here, if it's positive and positive, that will be spontaneous at high temperatures. Okay, so that means it's non-spontaneous at low temperatures. So at what temperature does it change over from spontaneous to non-spontaneous? And that's going to be then where delta G is equal to 0. If delta G is negative, it's spontaneous. If it's positive, it's non-spontaneous. So when delta G is 0, that's when it's going to become spontaneous. And it'll be any number higher than that will be a spontaneous reaction. Okay, so delta G equals 0. So we say delta G equals delta H minus T delta S. Put in 0. And then we can move the T delta S to the other side. So T delta S equals delta H. Solve for T, delta H over delta S. Now it's going to be plug and chug, except we have to watch our units. So the delta H is positive 119 kilojoules. And it's going to be divided by positive 263 joules per Kelvin. So we have kilojoules, we have joules. We can either change the top number into joules or change the bottom number into kilojoules. It really doesn't make a difference. I'm going to go ahead and change the top number. So 1 kilojoule is 1,000 joules. So my number here is going to be 119,000 joules divided by 263 joules per Kelvin. Okay, and that's going to end up being kelvins. And I get a value of 452 Kelvin. And that would be the temperature at which it changes from being non-spontaneous to spontaneous. And anything higher than that, so any temperature greater than 452, would be spontaneous. But I would say it becomes spontaneous at 452. Okay, last one down here is predict whether these entropy is increasing or decreasing. So I have a solid going to a liquid. Okay, that's definitely entropy increasing. I have 30-degree water going to 80-degree water. The temperature goes up, the entropy is increasing. I have a solid and a gas turning to solid. Okay, so my number of moles of gas is going down, so that's definitely a decrease. Liquid going to gas, that's increase. And a liquid going to liquid and gas, again, that's an increase. So all of these are increases except for C, which is a decrease in entropy. And that's the Quick Check 6.2.